So electronegativity is the ability to attract electrons. The trend is also up and to the right, and it's going to be the same reasons as our ionization energy. When you're comparing things in the same group or family, you should be referring to number of electrons or the number of energy levels, electron-electron repulsions, and distance from the nucleus. When you're going from left to right or right to left, or comparing elements in the same period, you should be referring to the effective nuclear charge. So why do you generally not see noble gases on electronegativity charts? So noble gases already have full outer shells, so they don't need any more valence electrons. Which would you expect to have a greater electronegativity, zinc or bromine, and explain why? Restart when you have an answer. Both zinc and bromine have 4 energy levels, but zinc only has 30 protons, while bromine has 35 protons. Therefore, bromine has a greater effective nuclear charge, which allows bromine to attract electrons better. Notice really the only thing that's changing from this and ionization energy is our ending. Instead of it saying that it's going to require more energy to remove an electron from bromine, now it says bromine is able to attract electrons better. Atomic radius is the distance between the radius of 2 atoms of an element. They have to measure the distance between 2 atoms of an element because the outer edge of the element is undefined. So radius is still the same as radius has always been. It's how big is the atom. For the trend, it's going to increase as you go left and down. It makes sense as you go down, it would get bigger. You're going to have more and more energy levels. If you have more energy levels, you have more electron-electron repulsions, which cause them to be further away from each other. And as I go to the left, I have less protons in the nucleus. So the electrons are able to go out further because they're not as pulled in. So this is just a multiple choice question, and since it's a multiple choice question, you can look at just the trend. Make sure you read carefully though. It says place these in order of increasing atomic radius. So if I was solving this problem, I would say, okay, well, increasing, well, first off, what's the trend for a radius? Okay, well, I know it increases as I go down, which means it must be to the left. So left and down, and I want increasing atomic radius, which means I should be going left and down. Well, if it said decreasing atomic radius, then I would say, okay, well, I want to go the opposite way. So find those elements and place them in order. Restart when you have the answer. You should have said B. This one's a free response, so for this one you're going to have to be able to explain why. It says, which would you expect to be larger, calcium or bromine atoms? So there they are in the periodic table. Restart when you have your reason. So you should have said both calcium and bromine have 4 energy levels, but calcium only has 20 protons, while bromine has 35. Therefore, bromine has a greater effective nuclear charge, which attracts the electrons more, reducing the radius of bromine. So on this one, we're comparing calcium and barium. Restart when you have your reason. You should have said that calcium only has 4 energy levels of electrons versus barium, which has 6. Since barium has more energy levels and more electron-electron repulsions, barium will be larger. Notice I'm being very specific on my answers. I'm not just saying calcium has less energy levels or barium has more energy levels. I'm saying how many each has, and then why does more energy levels matter? It has more repulsions, making it larger. Along with atomic radius, we have ionic radius. When comparing ions with their parent atom, they have the same nuclear charge. because they have the same number of protons, because they're the same element. Therefore, the size difference is due to the number of electrons. So it says, which would you expect to be larger, a calcium atom or a calcium ion? The first thing you should do when answering a question like this is list out your protons and your electrons. Well, calcium has 20 protons and it has 20 electrons because it's neutral. While calcium ion would be a +2 charge. So its protons have to be 20 because it's still calcium, but it's going to lose 2 electrons, giving it 18. So since both calcium and calcium ion have 20 protons, notice I'm basically saying they have the same nuclear charge. You have to have that they have the same protons, or they have the same nuclear charge. Since both calcium and calcium ion have 20 protons, but calcium atom has 20 electrons, while calcium ion only has 18, calcium has more electrons and therefore more electron-electron repulsions, making it larger. So more electrons, more electron-electron repulsions makes it larger. So go ahead and pause the video and try this one on your own. Restart when you have your answer. Both nickel +2 and nickel +3 both have 28 protons. But nickel +2 has 26 electrons and nickel +3 has 25 electrons. Since nickel +2 has more electrons, it has more electron-electron repulsions, making nickel +2 larger. And last one of these, go ahead and pause the video and try this one. Restart when you have your answer. So you should be a pro now. You should have said they both have 8 protons. But oxygen has 8 electrons and O-2 has 10 electrons. Therefore, O-2 has more electron-electron repulsions, making O-2 larger. The last thing is isoelectronic series. When a group of ions all contain the same number of electrons, they're referred to as isoelectronic. This group of ions are isoelectronic because they all have 10 electrons. When you're trying to figure out which is the largest or which is the smallest and they're isoelectronic, you're going to look at the protons and electrons. So list out the protons and electrons for each of these ions and think about it and decide who you think would be the largest and why. Restart when you think you know which one is the largest and have written your protons and electrons for each of them. So before we said they're isoelectronic. They all have 10 electrons. They have the same number as neon. But protons, they range from 8 to 13. So since they have the same number of electrons, we can't say that one has more electron-electron repulsions than another because they all have the same number of electrons. So it has to be their number of protons that's causing the size to be different. Oxygen has 8 protons pulling on those electrons, while aluminum has 13 protons pulling on those electrons. So if you said oxygen, you are correct. Since they all contain 10 electrons, the ion with the lowest nuclear charge would have the weakest attraction to the electrons, making it the largest. Therefore, O-2 would be the largest. And on your explanation, you'd want to make sure you had your protons and electrons either listed out on the page like I do here, or in the explanation, say oxygen had 8 protons, fluorine has 9, and so on. Therefore, oxygen had the least number, making it the weakest attraction. So we pretty much already answered this one. We said which one would have the smallest atomic radius and why. Well, aluminum then would have to have the smallest radius because it has the most protons. It's got the greatest nuclear charge. You can pause the video and fill in this part of your notes. Restart when you've written it down. So this question says, place the following order of increasing size. They don't have you explain anything, just put them in order. So they're ions. The first thing you want to do when you have ions is to figure out what is it isoelectronic with. So Be has a +2 charge. So if it loses 2 electrons, loses 1, loses 2, it would be isoelectronic with helium. Magnesium, if it loses 2 electrons, loses 1, loses 2, it would be isoelectronic with neon. Calcium, if it loses 2 electrons, 1, 2, it would be isoelectronic with argon. And finally, strontium, if it loses 2, 1, 2, it would be isoelectronic with krypton. So are these isoelectronic with each other? No. So they are ions, but they're not isoelectronic. So this question becomes very easy because we are just placing them in order of increasing size. Well, we can basically rank helium, neon, argon, and krypton in order. Strontium +2 would be the largest, and then calcium, then magnesium, and then beryllium ion would be the smallest. So since it says increasing size, technically they're already in order of increasing size. Go ahead and pause the video, figure out what these ions are isoelectronic with, and then rank them in order of increasing size. Restart when you have an answer. Neon is obviously isoelectronic with itself. Be, our boron, is helium. Neon, helium, krypton, and argon. So the smallest, I have 2 heliums. The more positive it is, the smaller it's going to be. So Be +3 is more positive than Be +2. Then I'm going to look at my neons. The more positive it is, the smaller it is. The more negative it is, the larger it is when they're isoelectronic with each other. So neon is neutral, and oxygen has a negative charge. And then krypton is bigger than argon, so that should have been your order. And finally, last one, put these in order of decreasing size. So figure out if they're isoelectronic, and then rank them. So for this one, they're all isoelectronic with krypton, which makes it easy because the more negative it is, we know the larger it is when they're isoelectronic. So decreasing size means big to small. So that's what you should have had as your answer.